Okay, now let's talk about geometric sequences. And they're similar to arithmetic in the sense that we're doing the same thing. However, we are not adding or subtracting. We are multiplying only. Some people might say, oh, multiply and divide. No, we multiply only, and I'll tell you why in a moment. Let's look at the first example. 1, 2, 4, 8, and 16. What are we multiplying these numbers to get to the next one? And you guessed it, we're actually multiplying by 2. Multiplying by 2. Well, in example number 2, though, we are, some people might say, hey, from 900 to 300, from 300 to 100, aren't we dividing by 3? Look, isn't that 100 divided by 3? And even though you're right, the formulas we're given do not deal with division. So we always need to keep it as multiplication. So instead of saying divided by 3, couldn't we just say multiplied by 1/3? Yes, there it is. So it's the same thing, guys. It's just that the formula wants to keep it multiplication. So what do I mean by the formulas? Check them out. So here's again the recursive formula. So we still start with the first term, and at the end, instead of calling it a common difference, we're calling it a common ratio, because ratios are the ones that get multiplied, not added or subtracted. So let's set up. We have 2 examples. Let's set up the recursive for the first one. Here we go. So for the first one, what's my first term? We said my first term, remember, we go by term numbers. Term number 1, term number 2, term number 3, etc. So my first term is 1. And at the end, we're going to multiply it by the common ratio, which was times 2. And that's it for that one. It's simple. Now, what about the second example? Well, my first term was 900, right? Term number 1 was 900. And what were you multiplying it by? Same thing over and over. You were multiplying by 1/3. So at the end, you would multiply it by 1/3. And that's it. That's recursive formula. Now, what about explicit? Explicit is, again, like in arithmetic, it's a little different. Here is the formula. It's, again, initial term, common ratio, but now you have a exponent on top. And that makes things a little more challenging. Let me tell you why. So for the first example, we have, again, my first term is 1. We're going to keep it that way. 1 times, what's in my common ratio? What was it? We're multiplying by 2, right? Multiplying by 2. So that's going to be a 2 to the power of n minus 1. So that's one way you could write the formula. However, if you don't remember from our last video, explicit formulas could be written in 2 different ways. Here's the first one. And the other one, you can actually simplify it. Let me show you how. If you don't remember your rules of exponents, guys, you can actually rewrite this exponent like this. Let me make this a little thicker right there. There we go. So it could be 1, not too much. There we go. Let's do that. So let's say 1 times, could I say this, guys? Times 2 to the power of n times 2 to the power of -1. Now, if you don't remember, when you have the same base, these get added into 2 to the power of n minus 1. That is an exponential. It's an exponential property you learn in middle school. So what I'm doing is I'm working backwards to break them apart. And I'm going to show you why. Now, 2 to the -1. Remember, that's the 2 to the power of -1 over 1. And we don't like negative exponents. If you don't remember how to make them positive, basically, if you have an exponent on top that's negative, you just bring it down. If it was at the bottom, you just bring it up. So my other way of writing this, it's 1 times 2 to the power of n times 1 over 2 to the first power. You notice how we made it positive? And basically, guys, what's 2 to the 1 power? 2 to the 1 power is just 2. So you don't need to write that exponent anymore. Finally, what can we combine? These two numbers. What's 1 times 1/2? It's basically 1/2 times 2 to the power of n. And if you really wanted to simplify this, we can multiply straight. My simplified formula would be 2 to the power of n over 2. We cannot reduce these guys because the 2 at the bottom doesn't have the n, you see? So it stays like that. I know it's a little tricky. You just got to remember your exponential properties. Let's do the other example. Once again, the other example was this one right there. My first term was 900. My second term was, my common ratio was 1/3. So let's apply. So the rule was, it goes initial term, parentheses, common ratio to the power of n minus 1. So that was 900 times, the common ratio was 1/3 to the power of n minus 1. Now this problem is a little more tricky because you have a fraction. But again, I'm going to take you through the steps. First of all, let's break it down. So we have 900 times, and like we did it before, let's break down the exponents to the power of n times 1/3 to the power of n minus 1. To the power of -1. There we go. Now here's what's going to happen though. If you don't remember this, you have technically two bases here. So because it is not just one number, you need to distribute that -1 to both, which you're going to end up having 900 times 1/3 to the power of n times 1 to the -1 power over 3 to the -1 power. You see what I just did? I just distributed to both numbers. Now here's the thing. Once again, we don't like negatives with exponents. So how do we make those exponents positive? Well, simple. This was going to be brought down to make it positive, and this was going to be brought up to make it positive. So we have 900, I always rewrite it, Mr. Mo, times 1/3 to the power of n, times, well, that's going to be, isn't that going to be 3 to the positive 1 over 1 to the positive 1? Yeah. Now, can we simplify this? What's 3 to the power of 1, guys? Isn't it just 3? Yeah. And what's 1 to the power of 1? Isn't that just 1? And even better, 3 over 1, isn't that just 3? Look how easy we simplified. And finally, the last step, what can we combine here? We can combine the 900 and the 3, which if we grab a calculator, 900 times 3 is 2,700 times 1/3 to the power of n. Again, it was a lot of steps, easy to make mistakes, but you need to be aware that this could be a possible answer on your homework, on the SAT, anywhere. So you need to know that there's two possible ways. That's the first one. That's the first one, and that's the second one.